Hello. Okay, it works. So I kind of actually planned for initial 10 minutes, then the agenda was really confusing. So I thought it's 15 minutes, I extended it, and turned out it's actually 10 minutes. So I need to skip a couple of things. But I hope it's going to be interesting still. So my name is Alex. I'm the team lead of EWASM and the co-lead of Solidity. And this talk is going to be a couple of insider infos from last year and this year from the team itself. I think this is the slide which can be tweeted as the most interesting one. So last year, 2018 was a really busy year. We grew the team to 9. Before that, for years, it's been only a 2.5% team. But we're a 9% team now, so we can achieve a lot more things than we could before. In 2018, we have made 8 releases. That's a lot of releases. I'm not sure how frequently you guys update, but I think people don't really upgrade frequently, and we push out all these changes so frequently, you should consider using them more frequently as well. One really big thing we did is finally releasing that breaking release. It took us 1.5 years, the 050. And we're really excited about it in the first 6 months. But after a year and it's still not being released, that was super annoying. So we finally got that behind us, we released it. And the last key point there is, in 2018, there were only 4 bugs found. Now the question is, does that mean that people are bad at finding bugs? Or are we bad at writing bugs? But I leave the answer to you guys to decide. I don't know the answer to that. Some tiny notes. 050 depends on a couple of things like Truffle and Zeppelin. Those are the releases you need to use to get 050 features. And regarding the 4 bugs, 2 out of the 4 bugs were fixed in the very last 04 release. And there's still a couple of big projects who pin their contracts to 0424. That's a really bad idea, because it has 2 bugs. You shouldn't do that. And I'm not sure why people really still want to stick with 040, because it's not maintained anymore. There won't be a 04 release. You have to move to 05. It's way better. Okay, we do have some takeaways based on 2018. The ecosystem is super complex. So I'm going to have a graph to explain that. Okay, these are 4 components. We have the compiler versions on the left. On the right, I wrote Truffle, but it's really frameworks, different frameworks. On the bottom right, it's Zeppelin, but it's not only Zeppelin, it's different libraries. And then, of course, your contract. So the contract depends on a compiler version, depends on a library version, depends on a framework version. The library depends on a framework. The framework depends on a compiler version. The library also depends on a compiler version. All of this is hard-coded. And we also depend on them. So the reason we depend on them is we take big projects and we use them during CI. We use them during testing. So every single change we do goes through a couple of different big projects. And it's an easy way to catch issues if you make any mistakes. And it also gives us a way to see how big of a scope, how big of a change it will be to make a breaking change in the compiler. How many libraries, how many the contracts it's going to break. So it's quite complex. And we need coordination between all these projects to get especially breaking changes out. But for any other change, something people need to update and it's pinned. So it's a lot of coordination between all these teams. But at the same time, we, as the Solidity team, we want really rapid changes. We don't want this slow cycle of 1.5 years to make a breaking change. This ecosystem is still early. We need to iterate much faster. At least that's how we look at it at Solidity. And the only way to achieve that with all these issues, with this big ecosystem, is by engaging more people. And by that, I not only mean library devs, framework devs, I mean you guys, app developers, and everybody else. There's no need to write code for the compiler. What we need is you guys engaging with us and telling us what you like, what you dislike, what would you change, yeah, stuff like that. So we just need you guys. Okay, so that was last year. And we have some crazy goals for this year. We want to make 1 release a month. Maybe even more, but at least 1 release a month. And we want to make at least 2 breaking releases this year. So this is like quite a big change from the previous 2 years. And the way our releases work now is ahead we decide the dates for the next 2 releases, and we don't move those dates. If we don't manage to implement every item on the wish list for those, we just skip a couple. But we just stick to the dates. So it's a frequent, known release schedule for you to pick it up. So these are a lot of releases, and you may ask, what the hell you guys want to put into those releases? I don't really see any changes. I don't know what should be changed. Well, we do have a lot of plans to change stuff. So here's a couple of things there we would like to change. I'm not sure if you guys know Yule, but a simple explanation is, today the compiler goes directly from Solidity source code to EVM bytecode. And we are trying to change that into a 2-step process. First, we translate Solidity source code into this intermediate version, and then we translate that to EVM. And by splitting this entire pipeline into 2, we can ensure that the 2 parts are better than the single one we had before. We can also apply optimizations into those 2 parts separately. And today, we only have 1 opportunity to do optimizations. The other big part, which is kind of connected to this, is the ABI encoder. So a quick explanation on that is the way to interact with contracts. You need to encode your input data and the output data in a specific way. And that is called the ABI specification, the contract ABI specification. And the ABI encoder is the piece of software which generates this decoder and encoder in the contracts. Still today, we use one which was written quite a while ago. It's quite complex within C++, and we have rewritten it in Yule, so it's, of course, way better. But it's not enabled yet. It's enabled through an experimental pragma. So people can use it, but they're afraid to use it because it's experimental. So we really want to enable it and get rid of the old one. I have some check marks there. It's a very random scale. 5 check marks mean it's done. So we're at 4 check marks for those things. And the optimizer, the 2 check marks doesn't mean that it's bad. It just means we can still improve it. We can add a lot of more things to make it better. The second half of the roadmap items, maybe I won't go into too much detail now because of time, but on the top, the Yule stuff is really just the lower half. And this is in order of importance and what we're going to achieve during the year. So maybe the second half of the year, we're going to have the other part. We're going to have Solidity to Yule, and then maybe even Yule to EWASM. A couple more things. Some check marks there. OK, the big news. Have you guys seen it? Yesterday, we made a release. It was just on the timeline. We just scheduled it. And here are a couple of interesting things we have changed in it. So this ABI stuff, it's pretty complete. It works. There's only 1 change left we want to make. But this one is really good at this point. The part you're going to notice when you start using 0.55, all these version numbers. So the part you're going to notice is that we changed the default version, the default target EVM version, from Byzantium to Constantinople/Petersburg. So now, if you just use the compiler as it is, it's going to generate code for Constantinople. You cannot choose it on another chain. But the compiler has a setting to change that. Truffle exposes that setting. Remix doesn't. So if you look for it in Remix, you won't find it yet. And by enabling Constantinople, we can make use of a couple of changes in Constantinople. And that means we can have a lot of gas savings. So one interesting thing here, you may know that Constantinople has bitwise shifting, which is a miracle on its own. Why the hell it wasn't included in the first place in the EVM? But it's now there. And we have this piece in the compiler called a constant optimizer. And what a constant optimizer is doing, it translates big literals, big numbers, into an expression. And this is controlled by the runs parameter. And the optimizer runs parameter is super confusing. It doesn't mean that how many runs the optimizer we're going to take. It has nothing to do with that. The optimizer always takes as many runs as it wants, as it seems it's feasible. You cannot control that. What that parameter actually means, we plan to rename it. And we plan to rename it to executions per deployment. So it basically just the expectation, how many times this code going to be executed on the chain. So if the number is low, that means you want to just deploy it once, and you won't really execute it too frequently. So the compiler will try to optimize this for deployment cost, that it should be a low deployment cost. But the execution cost might be higher, because you don't really run it frequently. Now, if you set the number high, you expect that it will be executed a lot of times. So you may be happy to pay a lot more gas to deploy it, but you want to save gas on execution time. And this code, it practically breaks up numbers into an expression of a shift and an addition. But before Constantinople, there was no shift. So it was an exponentiation and a multiplication. Really expensive. But with Constantinople, we can make that cheap. So if you guys go for which way? Yeah. If you guys go for like a less frequently executed contract and use a new compiler to compile it, it's going to be way cheaper than before. And that's like in the order of like 10 to 25% savings. The last point there is the OSS fuzz. Anybody knows anything about fuzzing? So fuzzing is a security/testing technique where you feed random information into the compiler and you try to break the compiler. So that's the goal. But you can do this like in a really dumb manner. You can just feed random stuff into it, and you may wait forever to get a crash or a problem. So fuzzing usually is a bit more advanced, and it, for example, takes a corpus of source files, a set of source files, and has algorithms to transform those. And it has a much better likelihood that those transformations are going to result in a source file which is accepted by the compiler and maybe even break the compiler. So OSS fuzz is a, how are we on time? Okay, so OSS fuzz is a project by Google. It's for open source projects. They can submit the code base, and Google gonna run fuzzing for them 24/7. In the past 2 years, the security team at the ETH has run fuzzing from time to time, but it was like a homegrown solution. OSS fuzz is way better. A lot of big companies, a lot of big projects use it. And we have like 3 different cases of Solidity being used in OSS fuzz. We just fuzz the actual compiler with Solidity source code, but we also fuzz it with Yule source code. And it has found, in the last like month and a half, it has found like 25 issues. But none of these are like big issues in terms of generating invalid code. It's more like issues at compilation time. You get like a wrong error, or it's a wrong message, or it crashes, or whatever. So it's nothing serious, but it still improves the compiler a lot. So that's like what we did in this year so far. And this is what next. Hopefully the next release is actually a breaking release. I don't even know what's the date set, but we do have the date set. And these are the big changes in it. So like the big one is this ABI stuff. It's going to be on by default. The other one is inheritance. During inheritance today, you can just override functions. Nobody complains. It's terrible. You don't know what the hell is going on. So that's going to be changed. There's going to be a requirement for a keyword to enforce that you can override something. So there's a keyword on the parent, and there's a keyword on the child contract. In the child contract, you have to say, I'm overriding this. In the parent, you're saying, I let you to override this. In any other case, there's going to be an error. And today, you can just do whatever you want. So that's going to change. The last point is somewhat related to this, because that's for variables. So today, you can just override variables. And the semantics is not fully clear what happens in that case. So that also going to be cleared up. And the abstract keyword for contracts, so like today, a contract, if it's missing functions, it's an abstract contract. So what that means, it won't produce you a bytecode. But the compiler doesn't tell you this. You just have to figure it out yourself. So that's going to be changed. There's going to be a keyword. If you set that keyword, the contract is going to be abstract. If you don't set the keyword and try to compile it, it's an error because it's not a complete contract. And that's like that link for the project board, where we plan all these issues. You can have a look at it. You can comment on those issues. You can propose new ones. You can also join our calls. And I really invite all of you to do that. So that was really just the update I had. I'm not sure if you have like time for like 1 or 2 questions if you guys have. But I would be happy to answer any questions. Oh, cool. Thank you, guys.